The cold dwarf planet Quaoar has a ring around it that is significantly farther away from its parent body than previously thought, which has perplexed astronomers. A whole new ring system has been found within the solar system, and it is so far from its dwarf planet parent that it shouldn't be feasible. Quaoar, which is about half the size of Pluto and is beyond Neptune, is encircled by the ring. It is the 8th ring system in the solar system and only 3rd ring to be discovered around a minor planet, with the most well-known and well-studied rings around the big planets Saturn, Jupiter, Neptune, and Uranus. How did the Webb Telescope find an improbable ring surrounding the far-off planet Dwarf? How did these stun the entire world? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. All 6 of the planets with ring systems have rings that are somewhat close to the planet's surface. Vic Dillon, a professor of physics and astronomy at the University of Sheffield in England, and a study co-author told Live Science that this seriously refutes our assumptions about how rings arise. In summary, the ring of Quaoar is great difficulty to theoretically explain because it was previously believed to be impossible to create rings that far away. Quaoar, a dwarf planet, has a ring that is too large for its figurative fingers. Quaoar's ring is substantially further away from its parent body than any other ring in the solar system, which all reside within or close to a distance that can be calculated. For Quaoar, it's very, very strange for the ring to be outside of this region, according to astronomer Bruno Morgado of the Federal University of Rio de Janeiro. The discovery could lead to a revision of the laws governing planetary rings. Quaoar is an ice object of the Kuiper Belt near the end of the solar system. That is about half the size of Pluto. It's challenging to have a good understanding of the world when you're so far away from Earth. So Morgado and co-workers observed Quaoar's obstruct a distant star's light, a phenomenon known as stellar occultation. The time of the star's appearance and disappearance can provide information on the Quaoar, such as size and whether or not it has an atmosphere. The researchers used information from occultations from 2018 to 2020 that were seen from space, as well as locations around Earth, including Namibia, Australia, and Grenada. There is no indication of Quaoar's atmosphere. Unexpectedly, there was a ring. Following the asteroid Chiriclo and the dwarf planet Huoma, Quaoar is currently the 3rd dwarf planet or asteroid in the solar system to be known to possess a ring as a result of the discovery. The Roche limit, an unseen line where the gravitational pull of the main body diminishes, is where known rings around other objects are located. Within the limit, that force has the power to shed a moon and transform it to a ring. Because the gravitational pull of smaller particles is greater outside than that of the main body, rings will eventually form one or more moons. We always think of it as straightforward, Morgado exclaims. On one side, the moon is forming, and on the other side, a steady ring. Moreover, this limit is no longer a limit, according to Morgado. There are a few plausible theories for Quaoar's far-off ring. Perhaps the viewers caught the ring just as it was about to transform into a moon. He observes that the good timing is unlikely. Perhaps the known moon of Quaoar, Weywot, or another undiscovered moon lends gravity to the ring's stability in some way. Alternatively, it's possible that the ring's atomic fragments are clashing in such a way that they don't hold together and form moons. For it to work, the particles would need to be exceptionally springy, like a ring for those bouncy balls from toy stores, said UCLA planetary scientist David Jewett, who was not involved in the new research. Jewett, who assisted in the 1990s in finding the first objects in the Kuiper Belt, affirms the validity of the observation. However, there is currently no way to determine which theory, if any, is accurate. This is due in part to the absence of theoretical predictions for such far-off rings to compare with Quaoar's circumstance. When it comes to the Kuiper Belt, that is typical. According to Jewett, basically everything in the Kuiper Belt has been discovered, not predicted. It is the antithesis of the traditional scientific paradigm in which predictions are made, verified, or rejected. When something unexpected is discovered, everyone tries to explain it. New observations of Quaoar or new finds of rings that appear to be misplaced elsewhere in the solar system could shed light on the situation. I have no doubt that many people will begin collaborating with Quaoar in the near future in an effort to discover the solution. The ring system is situated at a distance of 7 planetary radii, 7 times Quaoar's radius, which is twice as distant as the Roche limit, which is a theoretical only 3 planets radii away from the majority of them. It was previously believed that the rings above Roche limit couldn't live this far from their parent body. Rings that are formed outside Roche limits aren't meant to be stable. They should rapidly accrete into moonlets, using up to the ring material, explained Dylan, which now the ring is that much more beyond the Roche limits thanks to its finding. How a dwarf planet grew a distant ring. According to Dylan and his team, Quaoar's rings originated similarly to other rings in the solar system. A ring of rock, ice, and dust particles was formed by the collision of moonlets circling the parent planet. According to the researchers, if these particles are near the planet and inside the Roche limit, tidal forces from the planet body constantly tear them apart and prevent them from clumping, which prevents them from reforming a moonlet. But with Quoir's ring, that can't be the case. We need to figure out a means to prevent the moonlet from forming so far out, said Dillon. The particles in the ring are constantly colliding, and these collisions are elastic. It means that the particles can't stick together to form a moonlet. When two things collide in an elastic collision, they bounce away from another one as opposed to clumping together, much like a rubber ball hitting a floor. Dillon suggested that the elastic collisions would be possible if the ring particles have an icy outer layer, which is conceivable given Quoir's location at the outside of the solar system. To support this theory, more information is necessary. A chance discovery. While attempting to determine whether Quoir is an atmosphere, astronomers came across the ring system. The team made use of the high-speed Hypercam instrument on the Gran Telescopo Canaries, a telescope that can detect minute fluctuations in light from background stars and is located in Spain's Canary Islands. Before and after the main body of the Quoir crossed in front of the background star, the ring created a roughly 5% to 10% decrease in the star's light, making it observable. This occultation, as it is known, lasted less than a minute. The discovery came as somewhat of a surprise, according to Dillon. We weren't really looking for them, but when we knew there was a chance we might find them. Even with a tool as powerful as the Hubble Space Telescope, the ring of Quoir is much too small and dim to be observed via direct imaging. Dillon continued by saying that aside from occultation occurrences, sending a robotic probe to these dwarf planets would be the only method to see the rings. The extraordinary diversity of the things in our own cosmic neighborhood is demonstrated by this discovery, according to Dillon. You don't need to travel thousands of light years into the furthest reaches of the universe to encounter the unexpected. In our own solar system, there may still be plenty of surprises. A Saturn-like ring that shouldn't be there was discovered earlier this year on a tiny world beyond Neptune, with a diameter about equal to that of the Earth's moon. As of right presently, there are actually two of these impossible rings. It was a big surprise, said Christian Luciano Pereira, a doctorate student in Brazil's National Observatory who oversaw the Quoir studies of the entire planet. This suggests that Quoir is a more complicated system than we first believed. At a distance of roughly 1,500 miles, the new ring, which is about 6 miles wide, encircles Quoir. On Friday, the findings will be made public online in the journal Astronomy and Astrophysics letters. Why it matters. The formation of the moons and planets from the early solar system gas and dust is still a mystery to science. The second ring is outside of what is known as the Roche limit, just as the first ring orbiting Quoir, which is reported by a team of astronomers in February. Or a closely orbiting material is more susceptible to tidal pressures that drive it apart. Therefore, a ring of debris inside the Roche limit would typically stay that way, whereas the ring of debris outside the Roche limit would typically combine to form the moon. The Roche limit of Quoir is determined to be 1,100 miles. The second ring is closer than that announced in February, which has a radius of around 2,500 miles, and is located 1,500 miles from the center of Quoir. In the Kuiper Belt, an area of frozen debris beyond Neptune that also contains Pluto, Quoir orbits the Sun. Images taken with the telescope don't show the ring. Instead, it was discovered accidentally when far-off stars managed to pass behind Quoir and obstruct the starlight. Quoir crossed in front of 4 different stars between the years 2018 and 2021, and astronomers on Earth were able to see the shadows of these stellar occultations or eclipses. Additionally, they noticed some brightness fading before and after the star vanished, which indicated the presence of the first ring. On August 9th of the previous year, there were other occultation. The astronomers once more focused more large and tiny telescopes at Quoir in an effort to understand the ring better. More information was provided by the new observations, including the existence of a few miles of broad, compact, narrow core encircled by a more dispersed envelope of debris. The second ring was likewise made known by the observations. What's next? Observers using telescopes in the US and Canada will be able to see another occultation on May 13th. In addition to providing good opportunity to learn more about these two extraordinary rings, this event, which involves a brilliant star, will help to further constrain the Quoir shape, according to Mr. Pereira. The existence of a moon, Weywat, may provide an explanation of Quoir's distant rings. The moon might have caused gravitational anomalies that stopped the ring's particles from accreting into more moons. Both rings are located close to what is known as resonances with Weywat, and it may turn out that the resonances have a greater impact on the outcome than the Roche limit in terms of whether rings become moons or remain rings. What could we learn from these cutting-edge space explorers? Do let us know in the comments section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.